Hello. Today I am going to start exercise 7.2 question number 2. See, in question number 2 we have given you want to show that triangle ART is congruent to triangle PEN, in which you have to prove or you have to show if you have criteria SSS, then you need to show AR is equals to what, RT equals to what, and AT is equals to what. Similarly, in B, if it is given that angle T is equals to angle N and you are to use SAS criteria, then you need to show that RT equals to what and PN equals to what. And last, if it is given that AT is equals to PN and you are to use ASA criteria, you need to have we have to write the corresponding parts, or you need to show angles.
We have to show that these two triangles, triangle ART and triangle PEN, are congruent. Now these two angles T and N are given to us as equal. We also need to use SAS criterion, side angle side, right? So very clearly angle T and angle N need to be the included angles. So AT and RT are the relevant sides and PN and EN are the relevant sides. So the first part, well, RT of course will have to be equal to EN, which is the corresponding side, and PN, well, that will have to be equal to AT, which is the corresponding side.
Okay. Now see, here we have figures. Triangle ART, and this is triangle PEN. Okay. This is triangle ART and this is triangle PEN. So first is what? AR. Where is AR? This is AR. If AR is this, and we need to show here what is equals to AR. So see here, A and R is first two in this triangle. Similarly, PE is first two in this triangle. So the answer is AR equals to PE. AR equals to what? AR is equals to PE. Why? Because here AR is this first two and PE is here these first two. Now second is RT. RT is next to of this. So next to is EN. So where is RT? This is RT and RT is equals to EN. Okay. Now third is AT. What is AT? AT is the last, first and last. So here is AT and AT is equals to what? PN. This is PN. These are the corresponding part of congruent triangle. In B it is given that angle T is equals to angle N. So angle T, where is angle T? In triangle ART, you can see this is angle T. Angle T is equals to angle N we have given. Angle N. Angle T is equals to angle N. So with the criteria SAS, which two other sides are equal? RT is equals to what? Definitely RT is equals to EN, and PN equals to what? PN is equals to AT. Okay, these are the corresponding sides when angle T is equals to angle N. Okay, let's see once again. So in SAS we have a structure like this, okay? Two sides and angle between them. So if angle is T and here angle is N, so these two sides are what? AT and TR, and here PN equals to PN or and EN. Now in third, if AT is equals to PN, AT, this is AT equals to PN. Which two other angles are equal? So angle T is equals to angle N, okay? And the second one is what? Angle A equals to angle P. Which angle? Angle A is equals to angle P. So this is our question number 2. Let's see how you have tried in your copy. AR equals to PE, RT equals to EN, and AT equals to PN. B, RT equals to EN, PN equals to AT. And C, angle ATR equals to PNE and angle RAT equals to EPN. Okay, now next question, question number 3. You have to show that triangle AMP is congruent to triangle AMQ. In the following proofs, supply the missing reasons. So this is our triangle and these are the questions. We need to give the reason. Okay, so it is given to us triangle AMP. Which is triangle AMP? AMP. This is the triangle AMP. Left hand side. Which triangle? Left side triangle is AMP. And AMQ. AMQ is right side triangle. So what is the reason? PM equals to QM. PM is equals to QM. It is already mentioned in this figure. PM is equals to QM. Okay, so the reason will be given. In second, PMA is equals to QMA. PMA. PMA equals to QMA. What is PMA? PMA is an angle. PMA. This angle is PMA. And what about QMA? This is QMA. QMA. This is QMA angle. Okay, or you can say angle M. So it is also given to us. Now what is AM equals to AM? This is AM and this is also AM. Okay, so AM is the line which is common in both the triangle. Which triangle? PMA and QMA. So the third reason is common. And what about triangle AMP is congruent to triangle AMQ? What is the criteria? AMP is equals to AMQ. So this is side angle side. Given, common, and SCS as the two sides of the angle included between these sides of triangle AMP are equal to sides of and the angle included between these sides of triangle AMQ. So this is the answer of the third question. Now we are going to start next question. In question number 4, it is given in triangle ABC, angle A equals 30 degree, B equals to 40, C equals to 30. In triangle PQR, angle P 30 degree, Q 40 degree, and angle R 110 degree. A student says that triangle ABC is congruent to triangle PQR by AAA, angle congruency criteria. So we need to justify, is it true? Why or why not? In notes we have already studied about this such type of query. It is not possible that all angles is equal to, if it is possible then all angles of one triangle is equal to all angles of another triangle, or you can say the corresponding of angles of one triangle is equal to corresponding of angle of another triangle, but it cannot be shown that these triangles will superpose each other. I already show you the figure Once again I will show you the previous figure which I have given to you in examples. So for this, first we will write the answer like this. No, this property represents that these triangles have their respective angles of equal measure. Okay. However, this gives no information about their sides. The sides of these triangles have a ratio somewhat different than 1:1. Therefore, a property does not have the two triangles congruent. Okay, and this example I gave you in the notes part. Here we have given that all angles are equal to 60 degree, and here also all angles are equal to 60 degree, but their side is not meant to be equal. Okay, these sides are of 444 and this side is of 666, and here we can see that still the angles are equals, but the triangles are not congruent, or they are not looking equal, or we can say that they are not superpose each other. Why? Because this triangle is smaller than this one. So this is the best example to show congruency criteria is not possible. Now the next question. Question number 5. In the figure, the two triangles are congruent. The corresponding parts are marked. We can write triangle RAT is congruent to what? Okay, this is the figure. In the figure, two triangles are congruent. These two triangles are congruent and the corresponding parts are marked. These are marked. So we can write triangle RAT. RAT is what? RAT is congruent to what? So see, R is the first angle. Okay. So where is the first angle in another triangle? W is the first angle of another triangle. So it goes like this: R, then A. So W O T, W O N, R A T and W O N. So this is the way we will write the corresponding parts, or to write the triangle. Answer.
These two triangles are given to us and they are congruent. You see that? And the corresponding parts are marked very clearly. Right? Question is, we need to write triangle RAT is congruent to what? Now, let me first list down what is given. Angle RAT is equal to angle WON. Angle ART is equal to angle OWN. Angle RTA is equal to angle WNO. Now, triangle RAP is congruent to, now look at angle R. That is same as angle W. So corresponding to R, we write W. Look at angle A. That corresponds with angle O. So corresponding to A, we write O. And angle T, well, obviously we get the corresponding angle as N. So triangle RAT is congruent to triangle WON.
It can be observed that angle RAT is equals to WON, ART is equals to OWN, and AR equals to OW. Therefore, the triangle is RAT, which is congruent to WON by ASA criteria. Okay. Hope you understand this part. If you still have any doubt, you can comment me on the comment box. Now, next question, question number 6. Complete the congruency statement. Triangle BCA is congruent to what, and triangle QRS is equals to what? Here you have given the triangles. Okay. Hope you can do this question. Okay, let's see. Given that BC equals to BT and TA equals to CA, BA is common, therefore triangle BCA is congruent to BTA. Similarly, PQ equals to RS and TQ equals to QS. PT equals to RQ, therefore triangle QRS equals to triangle TPQ. This question is similar to the previous one, that's why I'm not explaining you. If you still have any doubt, you can ask me in the comment box. Okay, now next. In a squared sheet, draw two triangles of equal area such that the triangles are congruent. Second, the triangles are not congruent. So what can you say about their perimeters?
Now this is our squared sheet, and these are our two triangles, ABC and PQR. They have equal areas, and we've drawn them to be congruent. Let me tell you, congruent triangles will always have the same area anyway. What about the perimeter? Perimeter is the sum of the three sides, AB plus BC plus CA. And in case of PQR, it is PQ plus QR plus RP. Now, since the two triangles are congruent, well, their sides are equal. So, sum of the sides will obviously be equal. So, they will have the same perimeter. Now, in the second case, here are the two triangles that we've drawn. They are not congruent, as you can see, but their areas are the same. You see the bases? They are the same. The height, altitude, yes, that is same as well. And since the area is half into base into height, and base into height are same, so area is the same. But look at the three sides. Yes, the sum of the three sides in the two cases very clearly is not the same. So they have different perimeters.
See the first figure. Here, these two triangles are congruent and their areas are also equal. Okay, so here you can see that here triangle ABC and triangle PQR have the same area and are congruent to each other. Also, the perimeter of both the triangles will be the same. How you can say that? You can measure how many boxes are there. Okay, and with the help of butter paper, you can also prove this while superposing each other. It can be proved that their perimeters are equal. Okay, and one more thing, if the triangles are congruent, that means definitely their corresponding side must be equal. If the corresponding sides must be equal, then their perimeter are also equal. Now the next part, if the areas are equal but the triangles are not congruent. Here is the example of such kind of triangles. Here, the two triangles have the same height and base, thus their areas are equal. However, these triangles are not congruent to each other. All the perimeter of both the triangles will not be the same. So in this condition, if the sides are not equal, so definitely their perimeters will also not be equal. So with the easy manner you can understand this. In congruent triangles the sides are equal, so definitely their perimeter will be also equal. In non-congruent triangles their sides are not equal, so definitely their perimeters will not be the same or equal. Understand why? Because we know that the perimeter of a triangle is sum of all sides. Okay, now the next, ninth. If triangle ABC and triangle PQ are to be congruent, name one additional pair of corresponding parts. What criteria did you use? Here you can see triangle ABC is congruent to triangle PQR. So this angle is equal to this one and this angle is equals to this one. So additional part will be, so here we have two angles. What we have? Two angles. So definitely if we have two angles, so we want one side, and which side we want, so you write the answers on the comment box. Okay, next.
Here we are given two triangles, ABC and DEF. We also know that angle ABC equals angle DEF, each measuring 90 degrees. Angle BAC equals angle EFD, and sides BC and DE are of the same length. Now, are these two triangles congruent? In this case, we cannot use the ASA congruency criterion, as BC and DE are not the included sides of the two triangles. So what do? We will first try to prove the two remaining angles of the triangles to be equal. Now, two angles of triangle ABC are equal to two angles of triangle DEF. Recall the angle sum property of a triangle. The sum of the measures of the three angles of a triangle is always 180 degree. Now, what can we say? Can we say that the remaining angle of triangle ABC equals the remaining angle of triangle DEF? That is right. So we have angle BCA equal to triangle FDE. Now let us prove the two triangles to be congruent. We have angle ABC equals angle FED, each measuring 90 degrees. Angle BCA equals angle EDF. We just proved that. Also, BC is equal to ED. That was given to us. So now we have two angles and an included side in both the triangles. So we can safely say that triangle ABC is congruent to triangle FED. By which criterion? Right. AS.
So in question number 10, we need to explain why triangle ABC is congruent to triangle FED. Why it is saying like this? In triangle ABC, it is given that here we have continuous two angles are equal. Okay, and the third one is side, which is not follow the criteria of ASA, but it did follow the criteria of AAS. Why it is so? Why they are congruent? Let's see this question. It is given that triangle ABC is equals to angle FAD. ABC, this angle which is 90 degree equals to FAD, this angle. Okay. BAC equals to FAD. This angle is equals to this angle. These two angles are equal to the respective angles of FAD. Also, though we know that sum of all interior angles of the triangle is 180 degree, definitely the third angle will be also of equal measure. By this we can say that BC equals to EDF. BC is which angle? This one. Angle C is equals to angle D. It is also given that BC equals to ED. This side is equals to this side. So by using equation 1, 3 and 4, we obtain that triangle ABC is congruent to triangle FED with the criteria of ASA. Okay. So this is exceptional, or this was very important to understand what AAS can be applicable in the criteria. What AAS? Why? Because of this reason of angle sum property of a triangle. But AAA will not be applicable. Also, SSA or ASS will not be applicable. Okay. So that's all for today. We will do the next chapter in the next class. Thank you.